Okay, so what we're doing today is we are starting with, we're starting with absolute value equations, but we're going to part 2. Remember yesterday or the previous lesson we did some basic examples where the inside stayed the same, but you made the outside positive and negative. So we're doing that again today, but now we're adding in step 1, okay, and we're getting to some more difficult problems. So step 1 is to get the absolute value alone on the outside. And so let me show you what I mean by that. So let's say up here I have a problem 2, absolute value of x minus 3 equals 8. I can't have this 2 on the same side of the absolute value. You never distribute into absolute value, but I am going to divide by 2. And so now I have x minus 3 is equal to 4. And now the absolute value is alone, so then you can continue with this process. Okay? So that's what it means by get absolute value alone. You can't have anything on the same side as the absolute value. Right? And now determine if possible. Remember your absolute value must equal a positive. If it equals a negative, then it's a no solution and you stop. And then here you break it down to the two equations, the positive answer and the negative answer. And then I solve each equation. Now, the next thing we have is, this was new also, extraneous solutions are solutions that don't actually work. The ones that we're going to do that for is when we have x on both sides of the equation. So when you have x on both sides of the equation, we're going to do that. X on both sides. So like example B, that's when we'll check for extraneous. Okay, so let me show you example A. Now remember, it's the same process where nothing inside the absolute value changes. I have to get rid of this other stuff, so I'm going to draw my line down. The one that's farthest away is the 3, so I'm going to minus 3 on both sides. And so I get 2 absolute value of x minus 4 is equal to 4. And now this is 2 times, so I'm going to divide by 2. And so the absolute value of x minus 4 is 2. So I've gotten my absolute value alone. Now what I need to do is check to see if it works. Well, it equals a positive, so it does work. So I break it down to x minus 4 is positive 2, and x minus 4 is negative 2. To get rid of the minus 4, I add 4 on both sides. So x is 6. To get rid of the minus 4, I add 4 on both sides again, and I get 2. So those are your two answers. Okay, before we go up to example B, let's go ahead and try these problems down here that look like example A. What I'd like you to do is I would like you to try numbers 1 and 2. And then once you think you have them, press play. If you get stuck, press play along the way. Okay, so again, absolute value inside stays the same. So for number 1, the thing I need to get rid of is this minus 4. So I'm going to add 4 to both sides. And so I get the absolute value of x plus 3 is equal to 2. If you would have just looked at this, it equaled a negative, and you might have said, oh, it's a no solution. But remember, you cannot determine no solution until your absolute value is alone. Okay, so now my absolute value equals a positive, so I can break it down. So x plus 3 is 2, and x plus, geez, I keep doing that today. X plus 3 is negative 2. Okay, do not say this is a no solution because it equals a negative. We've checked for no solution right here. This is the last place you check for no solution. Once you get that past this step, you're going to have two answers, and neither of them are no solution. So now I'm minus 3 on both sides, so x is negative 1. Minus 3 on both sides, so x is negative 5. Okay. All right, for number 2, again, what's inside stays the same. Don't distribute. You can just keep that the same. But I do have to get rid of this times negative 3. So I'm going to divide both sides by negative 3. So I get the absolute value of 3x minus 5 is equal to negative 4. So my absolute value is alone, so now I look, and look, it's negative. Can't be negative, so that means it's a no solution. Okay, so last one, I'd like you to try on your own. I'd like you to try number 3 on your own, and when you think you're ready, go ahead and press play. So again, absolute value stays the same inside, but what does happen here, you may not see it, but this is a minus 1, right? So I'm going to start by getting rid of a minus 4. So it's negative 1 times the absolute value of x minus 7 equals negative 6. And again, it looks like it's going to be a no solution, but I have to get rid of this negative 1 first to see. And look what happened. That negative 1 turned it to a positive 6. So now I have x minus 7 equals 6, and x minus 7 equals negative 6. So I add 7 to both sides, and so I get x is 13. Add 7 to both sides, and I get x is 1. So remember, you cannot say it's no solution until you get here, until your absolute value is all alone. All right, let's go up and look at example B so that we're able to do the last 3 problems. Okay, so example B, I have 2 absolute values. Okay, what I do is I always keep the one on the left the same, because that's what we've been doing, right? And so my first equation is going to be 2x minus 3 is equal to just this, x plus 1. The second equation, remember, I'm supposed to make the answer negative, but look how I make it negative. I have to put a negative in the parentheses outside of it because I'm supposed to change both of them. So when I distribute that negative, it'll change both. So let's go ahead and solve this one. So I minus x on both sides. X minus 3 is 1. Add 3 on both sides, so x is 4. Over here, I had to distribute that negative 1, so I get negative x minus 1. I'm going to add x to both sides, and I get 3x minus 3 is equal to negative 1. Add 3, so 3x is 2, and divide by 3. So x is 2/3. So it's not exactly pretty, but it works. Now, you see that blue arrow hanging down? That's because we have to check for extraneous solutions. So I'm going to get a different color. So to check for extraneous solutions, I'm going to use this equation, and I'll plug in my x's. So for this first one, it'll be 2 times 4 minus 3 has to equal 4 plus 1. Okay, so 2 times 4 is 8. Minus 3 is 5, so it's the absolute value of 5 equals the absolute value of 5. That works. Okay, let's go over here and check this one. This is a fraction, so it's going to be a little harder. So 2 times 2 over 3 minus 3 has to equal 2 over 3 plus 1. Okay, so this is 4 over 3 minus 3. And this is 2/3 plus 1. Okay, so we're going to have to do some work with decimals. I'm going to come right up here. So if I put a 1 underneath this and a 1 underneath this, I have to multiply this by 3 and this by 3 to give me my common denominators. So I'm going to have 4 over 3 minus 9 over 3. And over here, I also have to do the same thing. Equals 2 over 3 plus 3 over 3. Okay, so 4 minus 9 is negative 5 over 3. And 2 plus 3 is 5 over 3. Okay, well, the absolute value of negative is equal to the absolute value of this one. So this also works. So both solutions work. So it can be difficult when you have fractions, but you can still do the math. All right, so what I'd like you to do is I'd like you to try number 4 on your own. And then once you think you have it, press play. Okay, so remember I keep the one on the left the same. And so it'll be x plus 3 is equal to 2x plus 12. And then over here, when I make it negative, it'll be x plus 3 is equal to negative 2x plus 12. Some of you might directly jump to this step where you just distribute the negative, which is fine. You just have to remember that you have to change both the signs. Okay, so I have minus 2x, and I get negative 1x plus 3 is 12, minus 3, so negative 1x is 9, divide by negative 1, so x is negative 9. So there's the first answer we have to check. Add 2x, so I get 3x plus 3 is negative 12. Subtract 3 on both sides, and you get 3x is negative 15. Divide by 3, and x is negative 5. So that's the next answer I have to check. Ooh, look at that. None of my answers are fraction. That's going to make it much nicer. Okay, so let's change colors. So it'll be the absolute value of 9 plus 3 equals the absolute value of 2 times, oops, that's supposed to be negative 9. Negative 9 plus 12. Okay, so negative 9 plus 3 is negative 6. 2 times negative 9 is negative 18. Plus 12 is negative 6. And those absolute values equal each other, so that answer works. This one I'm going to kind of squeeze up here. So 5 plus 3 is equal to, I keep forgetting my negatives. Negative 5 plus 3 is equal to 2 times negative 5 plus 12. So that's the absolute value of negative 2 and the absolute value of 2. Well, that works again. It does not happen that often that you get an extraneous solution, but you do sometimes. So we have to just deal with it and figure it out. So that's why you always have to check. Okay, last one. I'm going to highlight this. I don't distribute the 2 right now. What I will do is I'll distribute it in a second. So it's going to be 2 parentheses x minus 4 is equal to 3x plus 12. That's the first one. And then over here, it'll be 2 parentheses x minus 4. I'm going to go ahead and just change the signs. Negative 3x minus 12. So this is 2x minus 8, 3x plus 12. So that's going to be minus 3x. Negative 1x minus 8 is 12. Add 8 to both sides. So negative 1x is 20. And so x is negative 20 when I divide. So I have to check negative 20. Over here again, 2x minus 8, negative 3x minus 12. I'm going to add 3x on both sides. And I get 5x minus 8 is equal to negative 12. Add 8 to both sides. Uh-oh, we're going to get a fraction. And then I divide by 5. So x is negative 4/5. Okay, so that's going to be, this right over here is going to be my checking area. Takes up a lot of space, but I'm thinking maybe one of these might be extraneous, but maybe not. So 2 parentheses negative 20 minus 4 has to equal 3 times negative 20 plus 12. Okay, so this is 2 times negative 24. So the absolute value of negative 24 is positive 24. And 2 times 24 is 48. Okay, so let's see if we get that. So 3 times negative 20 is negative 60 plus 12, which is the absolute value of negative 48. And yes, that works. So we get a big check mark for this. Because if I take the absolute value of negative 48, I still get it. Okay, so let's try this one. 2 negative 4/5 minus 4 equals 3 times negative 4/5 plus 12. So I'm going to just go ahead and take care of this by multiplying by 5 so that I can get a fraction. Okay, so it's going to be 2 negative 4 minus 20 all over 5. Do this. I'm going to do the same thing here. I'm going to times by 5 so I can get that. So top times top right here, that's going to give me negative 12 over 5 plus 60 over 5. Okay, I need more space. Let's get some more space. Okay. So now, I'll go to red now. So now this is 2 times negative 24 over 5. So this absolute value of negative 24 is positive 24. So I get 48 over 5. And let's see, this one, negative 12 plus 60 is negative 48. So yeah, this one works also. So we haven't found one yet that doesn't work, but I promise you occasionally there are some that work that don't work, so you're just supposed to keep checking, okay? And sometimes checking is the hardest thing. If you have a nice calculator where you could just plug in 4/5 as a fraction or turn it into a decimal, you could also do that. You do not have to work with decimal or fractions if you feel uncomfortable. You can turn them into decimals and make this negative 0.8 and do the same process, and you will find out whether you get the same decimal. Okay, so these are definitely harder, especially those extraneous solution ones. But remember these steps. Get the absolute value alone. Determine if it's possible. If it's not possible, it's a no solution and you stop. Break it down to both and then solve the equation. And when you have x on both sides, you need to check for extraneous solutions.